everybody to the CEMS Live Tour. My name is Linda Schadler. I'm the Dean of the College of Engineering and Mathematical Sciences, and we're thrilled that you're joining us to see the new STEM complex. I hope as you go through and meet some of the faculty and students, you realize what a welcoming place this is and how many opportunities there are for interaction with faculty, both inside the classroom and outside the classroom, for both learning and professional development. Tonight, you will see me in the background, but we have two tour guides, Nick and Harrison, who will introduce themselves.
Hello, everybody. Thank you so much for joining us this Wednesday evening. My name is Nick Bowman. I'm a current junior majoring in mechanical engineering with a minor in computer science. I'm from Niskayuna, New York, so about 20 minutes outside of Albany, 3 hours south of here. And outside the classroom, I love to be outside. I'm a UVM outing club leader, so I lead day trips and overnight commute trips as well, and I train students that want to become leaders in the backcountry. Go over to Harrison.
Hello, you incredible people. My name is Harrison. I am a senior from Rochester, New York, studying civil engineering. Outside of the classroom, I am the captain of the steel bridge team. I'm also a big fan of outdoor recreation, skiing, hiking, biking, whatever I can do outside. And other than that, I am an avid member of the UVM Ski and Snowboard Club, which is the biggest ski club in the nation, just to plug that. So we're going to do our action straps, and we're going to start this tour.
Oh, yes. So before we get off to too much of a start, I just want to mention that closed captioning is available for the duration of this tour. You can select the 3 dots in the teams, and that should pop up as an option. And if you have any questions for us or any staff or faculty that we talk to, throw your questions in the chat. We're super happy to answer anything that we can. So, as we're walking this way, we've just come from Discovery Hall. This was finished in 2018 and it houses our chemistry and physics departments. Between Discovery and Innovation Hall behind me here, there are over 250,000 square feet of new labs. This is a part of a $104 million STEM complex expansion. Really, really cool stuff. And yeah, turn over to Harrison, talk about innovation.
And next, we're walking into Innovation, which was opened just in 2019. So it's got some really cool new lab equipment that we'll get to peek at. Right here is one of my favorite classrooms. I got to actually TA in this classroom, and it was really a dynamic workplace because you'll see all the computers and screens in this room. They actually allow for the teacher to beam stuff up on all the screens at once, or for students to do group work. All the tables are also very mobile, which helps both for COVID and for group work once COVID is done. And it makes for a really, really useful classroom, and it's being used for CS classes, all sorts of science classes, and pretty much anything. About 90% of students next year will have a class in this building, regardless of being in CEMS or any other major. So it brings together a really good mixing spot of people and builds a really good community, I believe.
What's your favorite class at UVM so far?
Ooh, I think this is a good question for Nick.
So one of my favorite classes that I've taken here at UVM is called Applied Thermodynamics, and it built on all these fundamental principles that we learned in Intro to Thermodynamics, but we just got to apply them in 3 major units, which it was so cool because that was really one of the first classes where I got to see all this material applied to real life scenarios. So this first unit we did focused on auto and diesel engines. We were looking at different aircraft and different automobiles and things of that nature. The next unit we completely moved on and looked at renewable energy. We're talking solar, wind, nuclear power, which was really cool to see how all those different things work and being able to relate that same material that we learned. And then we talked about heating and refrigeration and cooling. Really integral things that you don't think about super often, but are incorporated into every part of our society. So it was really nice to see that material that we've been learning and really studying super hard applied to everyday scenarios. So definitely one of my favorite classes with one of my favorite professors who hopefully will be seeing me on this tour.
Another question that came in, what kind of resources are there for entrepreneurship?
That's a pretty good question. I'll take a couple points and maybe Nick has a couple more. So a couple things outside of the college, we have residential learning communities that are centered around building entrepreneurial abilities to live with a community of people with like-minded interests, which really helps you develop your entrepreneurial skills, your communication skills and stuff like that. We've also got a lot of clubs that I think have a lot of entrepreneurial spirit. And not only that, but with like advising and stuff from professors, you'll get pointed towards a lot of funding that's accessible through the college. And there's a lot of advising to help you get into that kind of stuff. Is there any other specifics for entrepreneurship?
I think you covered it really well. I know I definitely get a fair share of emails from professors and students that are reaching out with different research opportunities or like summer co-op internship programs where you can really get involved, starting new clubs and things of that nature. You can also look through our career center too, if you're looking outside of the school as well, looking at different internship and research opportunities as well.
Yeah, and I'll just add, hope you don't mind, I jumped in here, but we do have various competitions where you can get funding if you have an idea for a company as well.
Yeah.
All right. Opportunities. Oh, yeah. Are there any other questions?
Yeah.
If there's any questions, throw them in the chat. But right now we're going to talk about computer science. Take it away.
So as computer science is my minor, I took, as a first year student, I took an intro to programming class. We learned about MATLAB, which was really, really fun. We got to do a bunch of really in-depth projects and learn how to apply it to real data analysis. I'll talk a little bit more about it upstairs as well. It's kind of hard to hear in the stairway. But yeah, I took this class with Professor Radhakrishna Dasari. I liked it so much. I did well enough in it where he emailed me at the end of the semester. He was like, hey, if you want to be a teaching assistant for this class, you're more than welcome. And I was like, yeah, absolutely. So I was a teaching assistant for him for 3 semesters. And at the end of each semester, he would take us out to this fantastic Burlington pizza joint way downtown. And we'd get together with all the TAs and learn a little bit more about him. So really great experience there, and I'll tell you a little bit more about comp sci on the next floor.
Great views of the library up here and the Central Campus Residence Hall.
So a little bit more about the Department of Computer Science. There's a wide array of different languages you can study. As I mentioned, MATLAB, Python, C, C++, Java. There's a lot of different research opportunities as well. As you can see, these are common spaces for undergraduate and graduate comp sci students who like to be doing work and research. A lot of the professors' offices are here as well. They are super accessible. I'm able to go even virtually through this pandemic to talk to my professors a couple of times a week because I have a lot of questions about the projects I'm doing, and they're really accessible and approachable. I've loved every professor I've had in this department. As a matter of fact, we're actually going to be talking to one in a moment here, luckily, and he's going to explain a little bit more about the comp sci department, get a little bit more in depth about the classes you may be able to take here as well. So,
when do you get to choose your classes and electives?
So when do you get to choose?
Yes.
So, I guess 3/4 of the way through a semester, you get to choose and look for the course catalog opens up for the following semester. And so for different semesters, you'll have requirements you can take. For a lot of the engineering and math majors, some of them may be built in or like preset for you, kind of like a curriculum builder throughout your 4 years here, but you can also choose different electives. You can take classes outside of this college as well. There's so many options and it's very comprehensive. And if you're in a class that you don't like as much or you want to take a different elective, there are add drop periods as well, so you're able to kind of move those classes around the first couple of weeks of the semester if you're feeling them out and want to try something a little bit different. That is anything?
No, that's fine.
Cool.
All right.
All right, yeah, we'll turn it over.
We'll turn it over to CS.
Hello, everyone. My name is Jason Hibler. I'm a faculty member in the Department of Computer Science. Welcome to the Department of Computer Science here at the University of Vermont. We're in a common area in our innovation building, a place where students like to come, work together, gather at a safe distance on class projects, for example. We have 370 undergraduates in the Department of Computer Science, 40 graduate students, master's and PhD students, and 18 faculty. The degrees we offer in the CS department are the Bachelor of Science in Computer Science, which follows a traditional CS curriculum, the Bachelor of Arts in Computer Science, which has room in it for a double major from a different department across the university, and the Bachelor of Science in Computer and Information Systems. For this third degree, students take several classes from the business school. This is the perfect degree for students who are interested in entrepreneurial aspects of creating, developing, marketing software. Within each of these degrees, in addition, we have several technical tracks to provide specialization in areas such as machine learning and programming languages, and cybersecurity. We're a growing department in terms of the number of students we have, the number of faculty we've had. Several faculty have joined us in the last couple of years, and we continue to grow both in the number of students and in the number of faculty. Our faculty are focused strongly on the experience of the undergraduates in computer science and are constantly bringing in teaching innovations such as project-based learning, the flipped classroom, in order to improve and enrich the experience for undergraduates in computer science. Our research faculty are engaged in problems of relevance, current relevance in the world, such as Professor Josh Bongard, who was one of the inventors of xenobots, which are synthetic computer-designed organisms for performing a specific task, such as drug delivery to a specific part of the human body. Professor Laurent Hébert-Dufresne is deeply involved in modeling the spread and transmission of COVID. And Professor Peter Dodds is the inventor of a software tool called the Hedonometer, which is used to gauge sentiment, the feeling of a broad group of people by analyzing millions of tweets every day. This has produced some interesting results during the last year of the pandemic, as you can imagine. However, it's not just graduate students who have the opportunity to work with our research faculty who are engaged in these vibrant research areas. Undergraduates as well can work alongside our research faculty in some of these areas. Our undergraduates have the opportunity, again, to work alongside our research faculty as well. Our students participate actively in internships, professional internships, and many employers come to the university and recruit our CS students for internships or for paid for full-time positions because of the great experience that they've had in the past recruiting students from the computer science department here at UVM. We have two student-led clubs as well, our CS Crew and the Society of Women in Computer Science. These clubs sponsor speakers, they sponsor hackathons, they provide a great way for students to network with each other outside of the classroom. And the last thing I'd like to tell you about is a program that we put in place a couple of years ago called Cat Coders. It matches our students who have software development skills with stakeholders from within the university or outside of the university who need custom software written. At the end of this, the stakeholders obtain the software that they need, the students gain valuable experience and skills, and in addition, we actually pay the students because we see the great value for our students of being in this role and gaining this experience. So that, in a nutshell, is the CS department at the University of Vermont.
And can you give some examples of where students work or go to graduate school?
Yeah, so we've had a student in the last couple of years go to Stanford, the top graduate school in computer science. We have a student next year who's going to Purdue University to continue studying computer science. Several students transition into either complex systems or into computer science at the graduate level here at UVM for continuity.
What about companies?
Our company. So we've had people go to Cisco, Citibank, Fidelity, the big companies. Also, so there's a vibrant software industry here in Burlington. A lot of students who are from Massachusetts want to go back to Boston. We have a student who's going to work full-time for a financial engineering company in Chicago. There's a huge variety of companies who come here and provide opportunities for our students.
Thank you so much.
You're quite welcome.
Does UVM have a co-op program?
Does UVM have a co-op program? We don't have a specific co-op program that students are required to do. You can get into one, but a lot of students do get into internships. Between us, we have 5 summers of internships, including the 2 upcoming internships we have. And that's been pretty amazing. Just talking about my internship experience, my first summer I interned for Chittenden County Regional Planning Commission in Winooski, which is a small regional transportation group that does a lot of work in the community. And that opened a lot of doors because they actually contract with a company called Stantec, which is just like an international company or whatever. So I got employed by them last summer as a transportation intern. And then this summer that's turning into a construction inspection position in Williston, which is going to be pretty sweet. I just accepted that job on like Monday or Friday or something like that. So it's been a pretty good week.
Absolutely. Oh, that sounds, congratulations. That's so cool. Yeah, and then my 2 internships I've had last summer and this upcoming summer are both and will be at Global Foundries over in Essex. Last summer I was an equipment engineer working in the photolithography department. And this summer I actually just got an email about what team I'll be on this summer. I'm on the chemical mechanical polishing team. I'm not totally sure what that entails yet, but I have a meeting tomorrow morning with my manager who just reached out to me, so that'll be a lot of fun. Yeah, so I guess we'll have one more floor. Sounds good.
We're going to go talk about math, statistics, all that. Please put them in the chat.
So we are now on the 4th floor, which is home to our Mass Mutual Center for Complex Systems. And they're doing some really incredible research, which kind of in short, they're really trying to quantify happiness and look at people who are admitted to hospitals and urgent care for mental health reasons and looking at their social media history and seeing if there are any patterns emerge. You can look it up online. It's thekeyDenominator.org. And it's tracing using Twitter data and large tweet streams during mass worldwide events. See, yeah, this is and you can actually map the levels of happiness of the general public based on if it's a holiday, obviously you'll see those rise, or if there's a tragedy, they go lower. And they're really just trying to quantify that, working into the UVM hospital and hospitals around the country. Really groundbreaking research that a lot of our faculty are involved in here. That's really unique.
Question from the audience. How is the collaboration between students in different STEM majors? Do students learning different subjects share and teach each other, whether formally or informally? And I presume the other part of that question is, or is it more competitive?
Yeah, I can start if you want anything on. Yeah. There is so many interdisciplinary opportunities within the College of Engineering and Mathematical Sciences, especially coming in. A lot of the majors are required, as I mentioned, to take that programming class and some intro design classes. And going up through your years, there are a lot of cross-listed classes. Next fall, I'll be taking a biomechanics class that's cross-listed between mechanical and biomedical engineering, which I'm so excited for. It sounds super interesting. But like I said, you can also take classes. I'm taking 2 electrical engineering classes right now, and a friend of mine who's an electrical engineering major has helped me immensely try to figure out how circuits work, because frankly, I have no idea, but she's helped me through it quite a bit. And through our SEED projects as well, our senior design projects, which we'll talk to a bit later, they're also interdisciplinary between certain engineering majors.
I think that question is also more around, is it a collaborative student environment?
I can totally answer that. So that's the thing I always harp on at the end of my tour. I talk about the most important thing I was looking at or feeling out when I was looking at schools was whether I got a competitive or collaborative vibe, because that can be very different in the engineering world, and I'm sure it applies to a lot of other STEM majors. But the University of Vermont is an incredibly collaborative environment. It's a very big community. And I think that applies very well to engineering in general, because that's the type of work that we go out into the industry to do, work with other people and become parts of teams. So we have a lot of project work that's integrated into our coursework. As he mentioned, we have the SEED program, we have the capstone program, which combines civil and environmental engineers, and we get to work together on projects. And as Nick mentioned, next we'll be talking to the math and statistics department, but all the intro math courses we took for 5 million maths, we took with everyone who was taking these math classes. So I met friends who are in different engineering disciplines that I didn't take a lot of classes with. I met people that were math majors that were absolutely incredible in helping me learn, and that I was able to help teach. So there's certainly a lot that helps when you have a learning community, if that answers that question.
Thank you.
Absolutely.
All right, and let's swing it over to math and statistics.
Hello. So, I'm in a student space here in the STEM complex. I actually don't know if you got to see one before, so I'll let you visit it a little bit. You can see the furniture is distant, so it's still open during the pandemic, which I think is a testament to how careful everybody has been keeping each other safe, that we can still have, you know, many of the things that make the UVN campus amazing happen this year. I'll let you get back in front of me so you can look at my props, especially the Golden Pie Trophy, which I will tell you more about in a minute. So as was mentioned, I'm here to represent the Department of Maths and Stats. We don't actually stay here. This is just a place I come for this tour. The department is big, so we're one of the big departments on campus, about 40 faculty. Every semester we teach about 4,000 students, obviously with repeats. So some people will take many math and stats classes in the same semester. As was mentioned, we teach all of the, I don't remember if it was 5,000 or 5 million required math courses that students need to take before they start their majors, but also the statistics courses that some students need to take in other majors. In addition to that, we teach a lot of really interesting courses that don't fit in those, you know, mandatory prerequisite courses like statistics of social justice, an introduction to data science class. One of my advisees is taking it this semester and she really loves it. She actually is going to take the next semester of it, the 100 level of it, next semester in the fall. She asked me to make sure it would fit in her schedule. And this semester I'm teaching a course on cryptography, and in particular on how quantum computers are going to affect cryptography in the future. And our students, my students, my students get to program a real quantum computer as part of the class. So IBM has quantum computers on the cloud that we can access for free, and they're doing that as part of the coursework. So it's really exciting. So we're definitely a department you want to be familiar with because there's a lot going on. Then once you get started in math, if you really feel the passion, you can become a math major or a math minor. We also have a statistics major and a statistics minor. So those are probably the usual program you're imagining, but we also have a new program, a new major in data science. And I want to highlight that one because I think not everybody knows yet, you know, maybe what the study of data science entails. And it's actually a multidisciplinary major where you'll take some math courses, some statistics courses, and some computer science courses, and they've been chosen to allow you to get a background in all of the disciplines that you need to be a master of to do data science. Now, it's not all study. We also have some opportunities for you to be involved in the community. We have peer advising for our majors. So first year students will be matched with either seniors or juniors to talk about, you know, course advising, social life. They'll take them to eat, you know, an ice cream cone by the lake to have a good chat. We have a statistics and data science journal club. So they meet, I believe, once a month. They have some pizza. I mean, not now, but they did have pizza. They will again next year. And talk about a journal article in statistics or data science. And math club, which is open to every, you know, math lover in the university, not just majors. And they do course advising. So right before the course schedule comes, well, right after actually, right before registration begins, but after the course schedule's out, they have a special meeting where all the students are invited, but faculty are not allowed to be there. And then they tell each other, you know, the truth about like which classes are good to take and what order you should do them. You know, so certain courses that don't come often, like you should really take that one. I took it 2 years ago when I was offered that kind of stuff. And we also have every semester a Math Bee, which is a competition of faculty against students. And the winner of the Math Bee gets the Golden Pie Trophy. So I believe that last semester faculty won it and graciously allowed me to have it with me for this tour of the building. In addition to academics and and social activities. We also offer research opportunity for our students. A lot of people are like super interested in doing that. There's RUs funded by the Dean's Office and CEMS, also funded by the National Science Foundation, so like our summer job. I've actually applied just yesterday for extra money to hire one of my students in my cartography class to continue working on something that I've talked about in class and I'm doing research on. So he'll be able to do research paid this summer on this topic. Our students also do internships. So like Keurig, the coffee company, is here in Vermont, not far. People do internships there. And then, you know, after that, what do you do? So people sometimes don't know what you can do. Like, what's a statistician? Someone who does statistics, does that pay any money? Yeah, it does actually. People really want students who graduated from math degrees or statistics degrees or data science degrees because it teaches you to solve problems in a rigorous way. So we have graduates who work, you know, for the Boston Red Sox, Citibank, the Mayo Clinic, Google. I mean, almost every big company needs, you know, mathematicians, statisticians, data scientists, but also startups. So one of my advisees who graduated a few years ago, she works for a small startup that tries to sell hotel rooms, like hotel.com, but smaller. So there's definitely a lot of opportunities, and we're excited to see you on campus. You have no idea, I'm teaching remotely all year, so when I say I'm excited to see you on campus next year, I like mean this even more than I would on a normal year.
Thank you, Professor Rinson. Thank you very much.
Welcome. I hope you have a great rest of your tour.
Onward to the engineering department.
All right, do we have any more questions before we head down some more stairs, some echoey stairs?
No, nothing that came through in the chat. Our class size is large or small?
It depends. We actually have 3 different class sizes. This will start off. We have a wild student.
This is our housemate Natalie.
So we've got, oh my God, sorry, I passed right by the stairs because I got excited about class sizes. So we've got 3 different class sizes. We have a lecture style classroom. We have a discussion-based or seminar-style classroom, and we have our traditional style classroom. So I thought I missed one. And so what lecture is, that's going to be your larger classes, your intro to insert your major name here, chemistry, physics, stuff like that. That'll be up to about 200 students, but those tend to break down into smaller groups, whether that's a recitation or a lab. After that, we also have our traditional style classrooms, which is sort of like your high school sized class. So you'll find that to be anywhere from like 25 to 45 students, depending on how big the classroom is. And that'll be a lot of your like math classes and stuff like that. And then as you progress further into your major or take more specific classes, you'll get into more discussion-based classes, which will be 20 people or less. I've had friends who are in a class of just 1 or 2 people, and the professor will actually take them out to lunch every week or something for like a discussion or at the end of the semester. So it fosters a really good community, and it's I think it's a really great way to learn. I'm in several traditional, or I'm in 2 traditional style classes and 2 discussion-based classes, and it's a good way to round out the senior year, let's say. We're gonna head downstairs. Alright. Next, we will be talking to the biomedical engineering department. So if you have any questions, please put them in the chat. What we're walking by right now is a bunch of research and lab spaces that are shared by our medical students, engineering students, chemistry, physics, and it's really an interdisciplinary way to get to do a lot of project work. My favorite thing about UVM is really like the hands-on learning that you can get outside of the classroom if you look for it. So this is a really great place to find that. Gotta watch out for this desk. Danger. And now we're gonna go talk to biomedical engineering.
Hello, hello.
We're here early this week.
Oh my goodness, exciting. I'm not sure I know what the word early means.
So this is Professor McGinnis, the Assistant Program Director for our Biomedical Engineering program, and Professor Rosen, who's been the Director of our Center for Biomedical Innovation.
Yes, I can tell you a little bit about our biomedical engineering program. So then
You want to walk around a minute,
yeah, let's do it.
like usual? I mean, as usual.
Excellent. Yeah, so our biomedical engineering program. Biomedical engineering is the newest engineering major on campus. We have about 150 undergraduate students. We're ABET accredited, and we have this really cool new curriculum that pairs the first 2 years are core technical training in key areas of biomedical engineering, and then we open up the curriculum so you can personalize your degree for the second 2 years and make sure that you get training in the areas that you need to make sure you can succeed in your career. We pair that technical training with some awesome design experiences starting your freshman year. We have a vertically integrated design curriculum that's enabled by our Center for Biomedical Innovation, and Dr. Rosen is going to tell you more about that.
Right, well, let's just fantasize for a moment. I'm talking to you out there. It's 2 years from now, you're in there, you're working on a project. Look around, what do you see? Most of all, you see students. All the projects that take place in there are undertaken by teams of students. Look around a little further, and yes, there's the occasional more professional looking person, faculty members from engineering, certainly, but also mentors from College of Medicine, from nursing, physical therapists, business people, etc. Now look at the benches, look at the projects. You're not seeing fundamental research, you're seeing the creation of new things, new technologies, new systems, new apps that serve a purpose in healthcare. And ask yourself about those projects. Are they homework assignments? Are they things that have been done 16 times before? No, they're all new, they're all novel, and they're all meant to meet the healthcare needs of Vermonters and people everywhere.
Can you give some examples of projects?
Yeah, sure. Imagine that you're a child lying in bed in intensive care because you've had a serious incident of some sort, and your arms are restrained, as they must be to keep you from pulling various tubes out. Meanwhile, those arms are also have access to interfaces for playing video games. So on that TV at the end of the bed, you are playing games by virtue of moving your arms about, which is good for your health, and also lets the doctor monitor how your progress is going.
Excellent. And can students in biomedical engineering go to medical school?
Absolutely. Our curriculum is super flexible, so you can take those electives that you need to get into medical school, and you actually have a really unique training as a biomedical engineer, so you think about problems in medicine much differently than other applicants to medical school do. So I think it makes you a more successful doctor in the end.
Wouldn't you rather have a doctor who was an engineer?
Absolutely.
Thank you both.
Thank you.
Thank you.
Yeah, that's interesting that you mentioned medical school. My friend Kylie is a biomedical engineer. She's on team at track right now, which is super exciting.
All right. And as we're walking across this bridge into the College of Engineering and Mathematical Science, very heart and home voting hall, we're going to start talking a little bit about research. The research opportunities here are boundless. It's really amazing. A lot of students get access to that, especially in STEM majors. But it's not only open for STEM majors. No, we want to talk before we.
Okay.
So About 40% of students are in research on average, which is really, really amazing. You can get opportunities through our Office of Undergraduate Research. You can also get these opportunities through crazy, just looking into the research that other professors are doing, emailing them, and then just being part of their team. So next we're going to talk to Jenna, who's actually one of my buddies who's gotten some amazing undergraduate research opportunities. So I'll turn it over to her. Hello.
Hello.
So tell us research.
Also research. So as Harrison said, my name is Jenna. I'm a senior here in the Department of Electrical Engineering. So I started doing research this past fall. Electrical engineering is a pretty small major, which means that my professors get to know each student like pretty personally. So I actually had my research advisor reach out to me in August and be like, hey, I know that you're interested in these things. I have research in this area. I think you'd be a good fit. And I looked more into it and realized that it was super interesting and really cool and something I wanted to do. So that's how I got into it. A little bit on what I am doing is we are using a software-defined radio, which is what this is, to create a interrogator, basically, for a passive sensor that we're using to monitor railroad beds. So overall, software-defined radios are really interesting and really cool and not something covered in any of your classes. So there's no other way I would have ever learned about these other than through research or just on your own. So it's been really cool to learn things, hands-on things that I didn't learn in my classes. Another good thing about research is it's an awesome resume builder. So having that on your resume gives you some good talking points where you can talk about things that you've done and problem solving that you've done, and really give you some good talking points during interviews.
Thank you, Jenna.
Yeah.
Thank you. That was incredible. One of my favorite points, besides her whole spiel, was her homage to resume builders and stuff like that. We have a lot of resources for career advising and stuff like that through the college and through the university, including being able to send your resume and cover letter electronically, getting it reviewed. So get used to using those sorts of resources wherever you go. And next we'll be talking to electrical engineering.
Good evening.
Hello.
Professor Kosorowako.
Welcome to one of our 5 teaching labs in the electrical and biomedical engineering department, specifically focusing on electrical engineering here. And so my name is Eva Kosorowako, and I'm a lecturer in this department. One very special thing about our program is the fact that throughout the 4 years of our curriculum, there is a design course in every single year, as well as labs every single semester. And so our students really take advantage of these facilities. And one quick example I was wanting to demonstrate is this system that our first year students would put together. In this case, I have a pressure sensor, and depending on how much force I'm applying to the sensor, you can see that the LED is changing color, but that also the voltage level is changing across the element. One possible application for this would be, for example, having a force sensor in your car seat, making sure that if there is a person sitting, that it sounds the alarm to make sure that you are clicking in. So a lot of different applications are possible in electrical engineering, and we designed our program to give our students a very good general education in electrical engineering, but we also have 3 focus areas, specifically energy system, autonomous systems, and computer systems. So are there any questions?
Can I study alternative energy?
Oh, absolutely. Electrical engineering is the right place for alternative and renewable energy. For example, currently I'm teaching a course on energy systems, and just today I talked about wind turbines. Isn't that right, Ethan?
Yep, I can hack an account for that.
Thank you very much.
Thank you.
Are there any questions in the chat that we can answer before we head downstairs?
What do you do on the weekends or in the evenings?
There are so many things to do, both on campus in the city of Burlington, and evenings on the weekends. Evenings in the week and the weekend are really popular to go watch the sunset. It's been ranked by a bunch of authors #2 in the world, behind some locations. Africa is the best sunset in the world. I just found that out a couple of days ago, which is really neat. Great place to get ice cream as well. The city of Burlington is super fun to hang around in. There's also always something going on campus. Our UVM program board puts on a bunch of activities for students all semester.
Excellent. Are there a lot of clubs you can join?
Yeah, there's a ton of clubs we'll be talking about. We have over 212 offered on campus, so just like baby numbers. But if you don't like any of those, you can also make your own club, as we talked a little bit more, or about a little bit earlier with the entrepreneurial spirit. We'll be talking about some more of the like STEM-based clubs, like Society of Women Engineers. Or we might not mention that when we go to the club space, but we have Society of Women Engineers, Society of Women in Computer Science,
National Society of Black Engineers, and then a bunch of these STEM-based, Society of Civil Engineers, Society of Mechanical Engineers. Yep.
Join your young professional society. It looks really good on your resume. Another resume builder. Out loud.
Ooh, woohoo!
We're going to take a look at one of my favorite places on campus, the UVM Fab Lab. There's so many opportunities for students to submit projects and work with classes of professors and 3D print, laser cut objects, you name it. And I'll have them explain to you a little bit more about what they do.
Hi, I'm Brooke. I'm a senior in mechanical engineering, and this is the university's makerspace, or as we call it here, Fab Lab. So here we work with students, faculty alike to facilitate hands-on projects, which you wouldn't otherwise get the chance to do. So it's a really good place to practice new skills and experiences in period of the learned class. These two machines right here are our newest machines. They're MakerBots, which allow us to run way more projects through here than we were able to previously. This one is printing a gear train for an obelisk gear, which is fun. These two white printers in the back are Ultimaker 3D printers. They're a fairly versatile desktop 3D printer. They can be used for a variety of different parts using different kinds of plastics, and they're our most utilitarian printer by far. So that's really good for getting a lot of parts through here at a high time. Those two gray printers print an ABS plastic, which has a much higher precision than you normally get on a regular desktop 3D printer. So for this, you're allowed to do a lot of different kinds of details that you wouldn't otherwise get, like very precise down to the micron, the hole diameters, grooves, things of that nature. And then this orange printer is a resin 3D printer, which has a really, really high level of detail and precision, almost close to injection molding, which allows you to do parts that you probably didn't think were possible on a 3D printer. It's completely different, a fully new form of printing that we're starting to learn here. We also have a laser, which is in the other room, because we have a fairly large laser cutter. So you can use that for a variety of projects. It's very, very versatile and very quick to use.
Can students work on personal projects here?
Yeah. Yeah, we're open to working with students on personal projects, classwork, research. If we can handle the project that you're doing, we're happy to help you make it.
Thank you very much. We also have our instructor for the introduction course in the entire college called CEMS 50. This is Professor Giles.
Hi, everybody. Yeah, so I teach CEMS 50. It's our first year seminar. So everybody who's new to the college comes to this course. So whether you're computer science, data science, statistics, math, and engineer, or if you're undeclared, you'll be in the course. So I think it's really fun. Basically, it's an opportunity for you to learn more about the different programs, learn more about the different extracurricular activities that you're hearing about today, and to learn some key skills that we think will help you succeed while you're here. So we focus a lot on design thinking and problem solving and teamwork and communication, and you do all of that by focusing on a semester-long project. The projects are worked on with 3 other students, so usually teams of 4, and the projects are all campus-based problems. They're new every year. So last fall, the project themes were around health and resources and energy at UVM. And some of the projects that students worked on were developing new functions for a campus-wide health app, figuring out what to do with food scraps and composting on campus, because composting is now a state law. We also had a project on harvesting rainwater from the student center roof for use in the toilets, so very sustainability focused. And at the end of the semester, you get together and we have a big poster session for all the projects where you present your solution with your team, and pretty much the entire CEMS community shows up to learn about what you came up with. We also have between 30 and 40 peer mentors that help to support the course and our first year students overall. So you'll be paired up with a peer mentor when you get here, and they'll kind of help you both on your project in the course, but just getting adjusted to life in the college and at UVM in general. And we meet in this space, so you have access to fabrication facilities, and yeah, this is kind of where the magic happens.
So how many students in a section at a time?
So this year we had, I think, 20 students spread between a couple of rooms, and next year we're going to have 45, hopefully we can get back up to capacity. But yeah, the whole course will be 300 some odd students. Yeah.
Thank you.
Hey, enjoy the rest of the course.
All right, next we'll be visiting the Materials and Structures Lab to talk about civil engineering, my absolute topic. So if you have any questions, please throw them in the chat, and I'd love to answer anything. Let's go. Look at that sustainable light going on there.
Do honors college students take classes with everyone else?
They do. They also have a bunch of classes that they get to take with honors college students, which means you're taking students from all across the University of Vermont and all 7 of our colleges, which is a really great way to work with a variety of students and really get a good balanced curriculum, I think, in general. Yeah, absolutely. All right, and we'll go talk about some civil engineering. Nice car, Hart.
Hello and welcome to the Materials and Structures Lab here at UVM. My name is Bob Worley. I'm a graduate student here. I also was a graduate in the civil engineering program, so it's a pretty decent program if I came back right. So this lab here, we test all there is about materials and how materials behave under different load conditions, stresses, and how they fail. We test things like little small members, like from wood, steel, to large composite materials, trusses, things like that. We have a nice little machine here. It's currently loaded with some wood to understand how wood might break under 3-point bending. Here's a piece that's already been loaded and broken. You can see how it breaks along the grain there. All things that you learn in wood design. We also have a large reaction frame. This is the newest piece of equipment within the structures lab. This reaction frame is pretty impressive. It can load in both compression and tension around 750,000 pounds on that middle aperture and about 110,000 pounds on the small aperture. Additionally, we do other small scale testing where students can get some hands-on experience with how in a truss bridge, how loads might be applied within different members under horizontal loading conditions, vertical loading conditions. Each one of these is a load cell that we can measure so that students kind of get a feel, different angles, different compression, tension, what are these individual members doing? Additionally, if we look at just small scale, brass, plastic, aluminum, or I have a steel bar loaded in here, we might be able to see how these fail under tension or compression. So if you're able to grab a little bit of that and a little bit of this screen, I'll start to apply some tensile stress, on this piece of steel, and it broke. So I'll have another piece here that's already broken, but we might be able to see the necking and see how that yields. So lots of small scale, large scale tests here, lots of hands-on work. So
Thank you.
see you in the material class.
Thank you very much. So how many students in CEMS and how many electrical engineers?
So overall in CEMS, we have around 1,400 students, and specifically in EE for electrical engineering, there are about 30 to 35 per year, so maybe like 120, 150 in that ballpark overall.
All right, we're coming up to the club space. This is where the American Society of Civil Engineers Steel Bridge team is housed, as well as our American Society of Mechanical Engineers, and our very own Aero team. We'd love to talk to them.
Hi.
Stick sweatshirt.
Thank you. My name is George Spearing. I am a junior mechanical engineer, and I'd like to introduce the Alternate Energy Racing Organization. If you look over here, you can see the awards we've won for the international competition of Formula Hybrid done in New Hampshire Motor Speedway. But what we do day by day is build this. This is the air car. It is an electrical race car. And we all work and take our theoretical knowledge that we've learned in class and use it to build a practical car. But if you're an engineer, don't worry, because we also have English majors, CS majors, marketing majors, and we all work together to build, problem solve, and create something absolutely fantastic. If you have any questions, please go to the UVM board page, the UVM clubs page, and start a discussion. So we'd love to talk.
How well do you do in the competitions?
Well, you can see a second place and third place. We usually do very well in documentation. We are right nipping on the bud for first place, so we will get there hopefully this year. Mm-hmm.
Thank you so much.
Thank you.
All right, so down at the end of the hallway here, we're going to be taking a look at our machine shop with some state-of-the-art equipment. I got to take a class in here my sophomore year, and we learned how to use all the business machinery equipment safely and professionally. Our final project, we got to build a hammer, like from scratch, which was really, really cool. And yeah, I will turn it over to our professional machinist, Floyd Gilmore.
Absolutely coolest guy in the sense.
100%.
Hello.
Hi, Floyd.
How you doing today?
Great.
Good. Well, welcome to the prototype laboratory. My name is Floyd Vilmont. I am the prototype manager as well as lead machinist, and I'm also the instructor for our AMB 81 practical machining class. So over here, when you first come in, you can see we got a lot of different things that we have built over the years. More recently, we have actually updated just about all of the equipment in the shop. As we take a walk through, we can see right here to my left, we actually have a Omax water jet. And as we go down through the shop, you can see up here we have also 2 new CNC machining centers. All right. And down at the very end of the shop, we have 2 new lathes, all new electronics on them. On the other side of the room here, we have 2 brand new knee mills as well with all new electronics. So some of the things that we do here in our shop, we support a lot of different activities. We support the senior design. We support all the club activities from aero to steel bridge to human-powered vehicles, as well as build devices for faculty. Down at the far end of the shop, we also have our welding area, which includes both TIG and MIG. In our shop, working with the senior designs, we have worked on everything from implantable lead repair components to working with the Vermont Maple Association to develop better ways to produce syrup. So there's no telling what we'll do in here. We'll try just about anything.
Thank you. I think you're working on CEMS awards right now.
Yes, we are actually. So we've got a lot of different things that are happening. It's a very busy time right now for us as well.
So,
Thank you so much.
well, thanks for coming in today. All right, next we're headed into the geomaterials lab where we're going to check out a pretty cool example of a project that a student got to put together while they were in their time here. So let's check it out.
Hello again, everybody. So this is the geomaterials lab. The geomaterials lab in geotechnical engineering, it's really the blend between the straight civil and environmental engineering. Really great specialty within civil engineering. It's where we learn all about soil mechanics, how water moves through soil. We also deal with composite materials such as concrete, where we do projects with recycled glass to try to make a little bit more sustainable concrete. We add different mixtures into concrete to make it a little bit lighter. There's a concrete canoe that ASCE does, so you might need a little bit lighter concrete for that. As alluded to earlier, this is one of the research projects that an undergraduate helped put together. So a little bit of hands-on experience outside and beyond the coursework. This is an augmented reality sandbox. So what you see on the screen is elevation banding to show high to low based on what's actually in the sandbox. So if we were to move some of this mountain down, not only does that color contour banding change on the display, but also on the screen. So additionally, if we put our hand over here, flat like this, we might get a little rainfall. I don't know if you can see up here on the screen. And that teaches a little bit about surface water hydrology, how water might move a little bit faster on steep slopes and a little bit slower on shallow slopes. Next project might be to add runoff coefficients to this to show that water runs faster over asphalt and slower over like a farm field. So maybe that's the next research project for the next student coming on board.
Thanks again, Bobby.
Yeah. All right, and next we'll be talking to a seed group, which is one of our senior design teams. This is one of our seed teams, which is combining biomedical engineers, electrical engineers, and mechanical engineers. It's a really great opportunity and another one of those resume builders. So we'll get to go talk to them about their project.
Hello, my name is Colin,
My name's Connor. And my name's Elliot.
and we're all currently senior biomedical engineers, and we're going to talk to you about our C project. So, as a senior engineer, you get a senior design project, and they're usually client-based and apply to real-world applications. And our client is the Associate Dean of the College of Agriculture and Life Sciences, and she has developed a research study to help people lose weight. And in the study, she wanted us to design a scale that could be used at home and could identify the person using the scale and send their information to the research study.
So Capstone Design is an iterative design project where each sprint is about 3 weeks long for a total of 7 sprints. So out in front of us are 3 examples of our different iterations of our scale here. This was an early on version. This is down in the middle, and this is pretty close to our final product. We utilize SolidWorks to design all of these components, and we use the UVM Fab Lab just upstairs for laser cutting and 3D printing services. And we also use the machine shop just across the hall to machine that piece of aluminum, which we're actually going to be doing tomorrow. If you look on the screen here, this is what our scale currently looks like. And after the aluminum is machined tomorrow, this is what our final product is going to be looking like. And then Elliot can speak more about the electronic components.
Yeah, so besides the mechanical engineering aspects of the project, we have a lot of electronics between Raspberry Pis, Arduinos, load cells, and batteries. This project requires Wi-Fi communication and putting information into a database. So I am a biomedical engineer, but I also have a concentration in computer science. So that's been really helpful with the databasing and other software aspects of the project as a whole.
Thank you guys so much. Do any of you get a job based on what you learned in this class?
Actually, our partner Mary has a job down in Vergennes at Collins Aerospace. It wasn't based on this project, but it was based on her, obviously her education here.
Yeah. And the agile framework we use, Scrum, is really helpful in a lot of employers ask about that in interviews. That's been a huge aspect of this program as a whole.
Excellent, thank you so much.
Thank you.
See that home earlier?
So we are getting towards the end of our tour. One last stop. If you have any more questions for us, please throw them in the chat. We're happy to answer them. We're going to stop by one of my favorite places on campus. We do a lot of really cool experiments here, Center for Mechanical Engineering, and so I'll turn it over and have him talk to you about that.
Howdy. I'm Doug Fletcher, Mechanical Engineering Department, and welcome to the Combined Thermal Fluids Lab for Mechanical Engineers and Hydraulics Lab for Civil and Environmental Engineers. And in this laboratory, there's one experiment that students from all programs do in common, and that's the buoyancy experiment that's set up over here. And this involves measuring at which surface water level the ball that covers the orifice looks off and allows the tank to drain. And they compare that with a calculation that they do from the principles of hydrostatics, where they're balancing hydrostatic forces. After that, the experiments diverge, and the civil and environmental engineers will work with this recirculating flume to study the effect of slopes and obstacles on flow rates. And then they'll work with the hydraulic bench test center to learn the principles of measuring flow rates in water supply systems, wastewater systems, and storm drains using things like B-notch meters. The mechanical engineers will transition to experiments done in pipe flows, where they will measure velocity profiles and velocity profile development. And then free jet flows, where we're going to make measurements with a pitot probe to look at the pressure evolution, looking at both the mean and fluctuating quantities for turbulent flow. And then they'll do several experiments with the wind tunnel, where they'll do a nozzle test and measure the pressure distribution in the nozzle to understand how the nozzle can accelerate airflow. And what you see set up in here now is a wing section where the students will take pressure measurements from all the taps around the wing, which you can see here. And the threads are indicating flow patterns. And when you reach a condition known as the stall condition, there's flow reversal on the top surface. And so those thread indicators will indicate that in real time during the test. So the students will record the pressures from the top surface, bottom surface, and the airfoil at different angles of attack. So that's the angle with respect to the incoming wind. And they'll calculate the lift and the drag of the airfoil for those conditions.
Could students design their own wing as part of a research project, or has that been done at all?
This has been done. We've had a number of students develop work with the force balance here to measure the drag coefficient for rockets that were part of another class experiment where they were launching the rockets and predicting at which height they would then turn around and come out. We also have a stock car model that somebody instrumented with pressure taps to, again, look at drag characteristics for typical NASCAR shapes.
So I hear we're getting a new ski safety lab. Can you talk about that?
Sure, that's going to be on the second floor of Bodie. In that laboratory, we'll install devices that can test boot and binding release characteristics under certain preload conditions, and these can be done for American standard testing methodology specifications or the International Ski Organization specifications. And we also have a ski flex tester that will be installed there and a boot stiffness tester. And all of that instrumentation was developed by a University of Vermont alumni back in the 1960s. And that led to the improvement of binding release characteristics that allows safer skiing for everybody today. We all kind of take that for granted. We just let the ski shop set them, but all of the information that guides the binding torque settings for use of ski safely came from that research.
Thank you so much.
You're welcome. Enjoy the rest of the tour.
All right, folks, and that sort of wraps up our tour. I would like to point out that there is a bunch of links that we've dropped in the chat, and we'll put up a couple emails that if you have any further questions, you can feel free to reach out to them. But we're going to sort of end by giving our little outros of why we chose the College of Engineering and Mathematical Sciences. And then we'll try to answer any questions in the chat if there's some of those. So I'll start off. So I chose UVM because my father was a very aggressive touree. When I came and toured UVM, afterwards he was like, let's go check out the College of Engineering and Mathematical Sciences. So it was a nice summer day, so it was beautiful and on campus. We got to that door that's right behind us right now, and it was locked, so I was like, thank goodness we can go and enjoy Burlington because it's the best place in the world. My father was like, no, let's just wait. So we waited, and it had been like 10 minutes, 20 minutes, and I was hanging around like looking at the bridges and stuff. But then I was coming up on 30 minutes and there was no one. And then at 30 minutes, someone's opened the door. We went inside. We found where civil engineering is located on the second floor. And we went to talk to the professor, Arnie Gomblies. And he was able to talk to us for like an hour and a half about civil engineering. And that was a really, really amazing experience for me and sort of showed me the community and sort of like connection between professors and students. That existed here. So that was sort of how I got my vibe with campus. I also decided on UVM by making a spreadsheet, which is the total like engineered way to do it. I wouldn't recommend doing that, but I would recommend looking for the things that you value most, and that will give you the opportunities that you need to be successful. And I think UVM had all the opportunities that I needed. When I calculated the A grade in a spreadsheet, I got a 96.6% match for this. And it has turned out very successful, and I love UVM. We'll turn it over to Nick.
I love that story. That's so fun. I started coming up to Burlington like first year of high school, sophomore year from soccer tournaments in June. So I really enjoyed coming up here. I come up with my family and friends and play soccer for like a long weekend, but I fell in love with the Burlington area. It's so beautiful. It's one of the few on a mountain in the morning and then stop in the city for lunch and like be at the beach in the evening. We have a beach, like I didn't know that, but we have one. It's really pretty. And then just coming on campus, as Harrison kind of touched on earlier, there was this large sense of support and a lot of collaboration versus competition. Being able to talk to some of the faculty and staff on like an admitted student day. Professors are always hyping up their research, doing some really cool stuff, but they're like, oh, check out what my friend's doing over here. And like super, as we mentioned before, interdisciplinary and so supportive. People love to help each other out. I love like talking about what my friends are doing because they're all doing super cool stuff. Also, I'm doing really cool stuff, and I'm just really enjoying my time here. I love to share information with people. I don't know if you got that from me being a tour guide. But whenever I toured UVM and I would go back to my high school and I'd be like, everybody, like, UVM has all these cool things that, yeah, we know, we get it. I'm like, no, like, listen, like, it's so cool. And being here for the last almost 3 years now has been incredible. All my professors have been really great, just so approachable and personable. Meeting people like Harrison and just all these great connections I've made in the College of Engineering and outside of it is so special, especially meeting people that aren't necessarily in engineering as well. You get a really holistic view of like a thrilled society. There's so many connections here. So as Harrison mentioned, love my time here. I can't say enough about it. And I encourage you to, I wish you the best of luck in your college search. If you up there, I wish you the best of luck.
Cool. Any questions? All right, we'll see you soon.